Welcome to Laws of Indices Level 5. Pause the video now, try the 4 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're told that x to the power of 3 over 2 is equal to 27, and we need to find the value of x. Now, since the expression on the left-hand side of the equation has a fractional power, we can use this law, which tells us that the numerator of the fraction is the power and the denominator is the root. So this means that x to the power of 3 over 2 is equal to 27 can be rewritten as x to the power of 3, and then the square root of that is equal to 27. Looking at the left-hand side of this equation, we can remove the square root by squaring both sides. And if we do this, we have x cubed is equal to 27 squared. To now remove the cubed on the x, we can take the cube root of both sides. And this gives us x is equal to the cube root of 27 squared. If we now start with the cube root of 27, this gives us 3, because 3 times 3 times 3 is 27. So x is equal to 3, still with a power of 2 on it. Finally, 3 squared is 3 times 3, which is 9, so our final answer for problem 1 is x is equal to 9. In problem 2, we're told that 8 times 2 to the power of n is equal to 4, and we need to find the value of n. To help us solve equations like these, we'd like to write each value to a power of the same number. And we notice that 8, 2 and 4 can all be written as powers of 2. So this means that 8 multiplied by 2 to the power of n is equal to 4 can be rewritten as 2 to the power of 3, because 2 times 2 times 2 is 8, multiplied by 2 to the power of n is equal to 2 squared, because 2 squared is 4. Looking at the left-hand side of the equation, we now have the same base, and this means that we can use our laws of indices. So we can use this law to multiply together 2 to the power of 3 and 2 to the power of n, and this gives us 2 to the power of 3 plus n, and this is still equal to 2 to the power of 2. Now that we have the same base, which is 2, on both sides of the equation, we can say that the powers on each side of the equation must be equal to each other. And this means that 3 plus n must be equal to 2. We can now solve this equation by subtracting 3 from both sides, and we get to our final answer, which is n is equal to 2 minus 3, which is minus 1. In problem 3, we're told that 4 to the power of m is equal to 1 over 16, and we need to find the value of m. Now, in order to use our laws of indices, we need to write each side of the equation as a power of the same number. And we can see that 4 and 16 can both be written as powers of 4. So starting there, 4 to the power of m is equal to 1 over 16, becomes 4 to the power of m is equal to 1 over 4 squared. Now the right-hand side of the equation can be rewritten using this law, and 1 over 4 squared becomes 4 to the power of minus 2. The left-hand side is still 4 to the power of m. Now that we have the same base on both sides of the equation, which is 4, we can say that the powers must be equal to each other. This means that m must be equal to minus 2, and this is our final answer for problem 3. In problem 4, we're told that 27 to the power of p divided by 9 to the power of 3 is equal to 3, and we need to find the value of p. Now once again, in equations like these, we'd like to write each value to the power of the same number. And we notice here that 27, 9 and 3 can all be written as powers of 3. And this means that 27 to the power of p divided by 9 to the power of 3 is equal to 3 can be rewritten as 3 to the power of 3, because 27 is 3 times 3 times 3, still with the power of p on it, divided by 3 to the power of 2, because 3 times 3 is 9, still with the power of 3 on it, and that's equal to 3, which we can also write as 3 to the power of 1. Now, since on the left-hand side we have powers raised to powers, we can use this law, which tells us that in order to simplify these expressions, we need to just multiply the powers together. So starting with 3 times p, we have 3 to the power of 3p, divided by 2 times 3 is 6, so the next term becomes 3 to the power of 6, and that's equal to 3 to the power of 1. Now on the left-hand side, we're dividing indices with the same base, so we can use this law. And this law tells us that we can subtract the powers when we're simplifying. So 3 to the power of 3p divided by 3 to the power of 6 becomes 3 to the power of 3p minus 6, and that's equal to 3 to the power of 1. Now, since the base on each side of our equation is the same, we can say that the powers must be equal to each other. And so this means that 3p minus 6 must be equal to 1. We can now solve this equation by adding 6 to both sides, and this gives us 3p is equal to 7, and then dividing by 3 on both sides gives us p is equal to 7 over 3. And that's our final answer for problem 4.